Good morning, my dear students. In continuation to whatever we learned in today's morning Zoom class, I would like to solve a numerical for all of you. So I want all of you to take out your copy, not copy and pen, and please kindly copy down this question first, okay, and then solve as I solve along with you, okay. So let's get started, all of you. So I just read the question for all of you here. It's written here: the enthalpies of formation of carbon monoxide gas, carbon dioxide gas, and dinitrogen oxide gas and dinitrogen tetroxide gas are minus 110, minus 393, 81, and 9.7 kilojoule per mole respectively. So you have to find the value of delta RH. My dear students, delta RH is nothing but it is the enthalpy change of the reaction, okay, for a particular reaction. This reaction is given. So first of all, I use a different color pen here. Okay, first of all, I'm going to write the reaction for everyone here. Okay, first and foremost, you have to write given reaction. Okay, so given reaction, my dear students, I want you to write this reaction once more. N2O4 gas plus 3CO gas gives N2O gas plus 3CO2 gas. So this is a given reaction, my dear students. So we'll be solving this sum now, right? So first of all, my dear students, you should remember a formula. Okay, right now we know that delta RH, okay, delta RH means enthalpy change of the reaction. So it has got a beautiful formula. The formula is summation of delta FH of products minus summation of delta FH of reactants. So this formula has to be remembered. Okay, this is how you find out the enthalpy change of any reaction. Okay, so I'll just simply, what I do is I'll sum up all the enthalpies of the products, and then I'll subtract with the summation of all the enthalpies of the reactants. I hope you're clear of it. Okay, so I'll just put the formula, put the values. Okay, first, my dear students, I can put an A here, okay, and I can put a B here. Okay, A stands for number of moles of products, and B stands for number of moles of reactants. Okay, if you want, you can put that. If you don't want, you can just like avoid it. Okay, I leave that to you. Okay, so my dear students, the products are all on the right hand side of the reaction, and the reactants are all on the left hand side of the reaction, this particular reaction. So if you see on the rightmost side of the reaction, you see N2 gas and you see CO2 gas. Okay, so you see only 1 mole. Okay, only 1 mole of NO2 is present, so you just multiply 1 into N2O gas. Okay, so for that we are going to actually take the value. We are going to actually take the value of that particular enthalpy there. Okay, so we write 1 into delta FH of your N2 gas. Okay, N2 gas, N2 gas, N2O gas, N2O gas. All right, and you're going to add it with the 3 moles that is present over here. 3 into delta F. Okay, delta F means you know it, enthalpy change of formation of CO2 gas, and then you're going to subtract it because there's a minus sign over here. You're going to subtract it with the summation of all the enthalpies of all the reactants. Okay, so 1 mole of N2O4 is present, so 1 into delta FH of N2O4 gas, and you know it's a summation, so you'll plus with 3 moles. Okay, 3 moles of delta FH of CO gas. So that's how you're going to do it. Now what you have to do is you have to simply substitute the given values in this equation. So you get 1 into, my dear students, what is N2 gas? You can see here N2 gas, enthalpy is given. N2O gas is given here. Okay, on the third side, yeah, this one. All right, the third one. So it is 1 into 81 plus 3 into कार्बन डाइऑक्साइड गैस का एंथैल्पी क्या दिया है, कार्बन डाइऑक्साइड गैस का एंथैल्पी दिया है द सेकेंड वन, राइट, -3 93. All right, and then you can put a bracket here, minus 1 into N2O4. What is N2O4 value there? N2O4 is given here 9.7. 9.7 plus, now the next one, 3 into carbon monoxide gas. Carbon monoxide gas is given carbon monoxide gas, okay, the first one, yeah, minus 110 is given there. So you can just simply use your calculator and solve this. I'm using mine right now. 393 into 3, I'm getting here minus 1179, and then subtract it with 9.7 minus 330. So I'll just rough what is there. I'll just rough this. I'll just rough this question here. And on solving, you can pause the video and write it down, okay, in the meanwhile. So I'll just solve this. 81 minus your 1179, I'm getting here minus 1098, minus, if I do this 9.7 minus 330, I'm using my calculator here, I'm getting here minus of 320.3. So you know, my dear students, minus 1098 minus minus plus 320.3. If I simply add it up, 1098, I'm getting here minus 777.7. So the answer will be coming out to be kilojoule per mole, okay, or you can simply write, yeah, kilojoule per mole. Okay, so this is the required answer, and this is your enthalpy change of the reaction. So I hope all of you have understood this video. So kindly write it down in your copy. Thanks a lot for watching. It's Mr. Renji signing off. Bye bye. Have a nice day.